Anthony here for D-News, and we have talked about 3D printing before, how soon we'll be able to print our own household objects, our own cars, how it's going to change our lives entirely. But wait, at TED this week, MIT's Skylar Tibbetts presented his work on 4D printing, and that is one more than 3. So, what does that actually mean? Well, it means printing objects that change after they're printed. Basically, printing a raw material that folds into the shape of the final object, like printing a sheet of paper that turns itself into origami. It basically works by printing a long strand of plastic that's made of 2 different polymers that react differently to water. One expands and one contracts, and by intelligently mixing the 2 based on blueprints, the strand folds itself into the shape of the final object. Right now, it only makes 2 tiny objects, one that spells out MIT and one that makes a little cube. But the big idea is that eventually we'll be able to send a huge printer down into the ocean that could build us a lab, or up into space to build us a space station. You could make things like water pipes that expand and contract, which would eliminate the need for pumps and other machinery that could break down. Imagine machines that have no moving parts to repair, because smart materials and manufacturing are going to change every object in the world around us.
A team of researchers from MIT and UMass Amherst have designed 3D printed structures that can fold themselves up without any outside stimulus, and the folding begins the instant it is peeled off the printing platform. The key to these new self-folding designs? A new printer ink material the team developed that actually expands after it solidifies. This poses a challenge, as printed electronics typically tend to degrade when exposed to heat or moisture. A folding process that does not require an external stimulus enables self-folding parts with functional electronics.